All right, hello. I'm Gavin, and we're going to be going over written response for your midterm that's coming up on Thursday. And hopefully this video is helpful to you all. You can feel free to skip forward to whichever problem you're looking at. Um, but before we get started with the actual short answer problems, I want to just briefly go over a couple of concepts from chapters 12 and 13 that I think are like very important. So first of all, chapter 12 is the cost of production. And there's going to be the total cost, there's going to be the variable cost, and there's going to be the fixed cost. So the relationship between these three costs are total cost is equal to the variable cost plus the fixed cost. But now, as you can probably tell by these equations in chapter 13, we're interested in the average of these. So this is our first important equation here. But now, if we're interested in finding the average total cost, we can find that the average total cost is equal to the average variable cost plus the average fixed cost, because you are just taking averages of everything. So that works out. But another way that you can think about it is the average total cost is the total cost divided by the quantity of output. So that's what an average is. Whenever you're taking an average of something, think that you're dividing it by the quantity, divided by a quantity. Okay. So then, if we're looking at average variable cost, that's just going to be the total variable cost divided by the quantity. And then the average fixed cost is equal to the total fixed cost divided by the quantity. So hopefully you can tell that these three equations are very similar, and to get the average, you just divide by the quantity. So it's not that you have to memorize three different equations. You just divide the total by quantity, and that gives you the average. So then the last cost that we have to look at is marginal cost. And marginal cost is a little bit tricky, but it's the change in total cost divided by the change in quantity. So if I increase my quantity by one, so if I make one more unit, how much more did it cost me to produce that additional unit? And this leads me to a quick little side note. I had this economics professor that would always have us do this exercise. She would say, when I say marginal, you say, and then we all had to say additional. So the marginal cost is just the additional cost of producing one more unit of the good. So those are your cost curves. Now sorry for moving the screen so much. Now for the chapter 13, which is all about perfect competition. We see all these cost curves, and they might look very confusing at first. They're just a bunch of lines. What do they mean? So I created this like visual to kind of help you figure out, are we making a profit? Are we making a loss? What should we do in the short run? What should we do in the long run? So anytime that the price is greater than the average total cost, so anytime the price is in this area, anywhere above the average total cost, you're going to be making an economic profit. So anytime price is in the blue, anytime price is greater than the average total cost, you're making an economic profit. And if you're a firm, you're very happy to be making economic profit. That means you're making more money selling the good that you're currently selling than you could be doing anything else. And then accounting profit is the break-even point where price is equal to average total cost. And that's still good. You're still going to stay in the short run and in the long run, because if you're making a profit, or in this case, if you're making accounting profit, you're going to want to stay in the market. So now when we get into the yellow in this part here, where the price is below the average total cost. So the price is below the average total cost. we're making a loss because you sell the good. Let's say that this is like $5 here. You're selling the good for $5, which is this yellow line, but then it costs you because the average total cost is telling you how much it costs you on average to produce the good. Let's say that's $6. So that means that you're selling the good for $5, but it cost you $6 to make the good. So that's why you're at a loss the price is if the average total cost is greater than the price. So you're still going to want to stay in the market in the short run because you're still able to chip away at those fixed costs. It's only when the price falls below the average variable costs. Yeah, average variable cost. So anytime you're in the red, that's like very bad. So think about like anytime that you're in a price in the red, um, if this is like the market for pizzas, you can't even sell a pizza for how much it costs you to make the ingredients, for how much it costs you to like buy the ingredients to make the pizza. So hopefully this visual helps you. And now moving into the short answer. So first we're taking a look at perfect competition. By the way, please try to practice these by yourself first or with like a friend, and then check your answers with me. So then you're able to like fully make sure you understand it. So for part A, first of all, this is the cost structure of a firm in a perfectly competitive market. So we're using both of these graphs. So with perfect competition, you have to realize that there is going to be the market graph, and then there's going to be the individual firm. So there's two graphs for this because there's in perfect competition, we say that there's so many individual firms. So this is just the one firm. But then if you take a look at the entire market as a whole, so you like add up all of these individual firms, you get the market. And you can see that in the quantity axis. Here, the quantity for the market is in millions, whereas here it's only going up to like 100 maximum. So that shows you that the individual firm is very minuscule compared to the market. So now, what's really fun about part A is that you could probably answer this question before you even took the first midterm for this class, because it's just asking what the market price and quantity is. We've been doing this since chapter 3. You find where supply intersects demand, and that is going to give you a price of $7 and a quantity of 30 units, 30 million units. Be sure to check the labels. So price equals $7, and then the quantity is equal to 30 million. All right, now for part B. What quantity does this firm produce to maximize its profits given the market price? Okay, so now we're going to be taking a look at the individual firm. So now we have to bring over, so we're saying that the market is charging $7. So you can just draw a horizontal line all the way straight out like this, and that will tell you what the market price is. And now you look at it for the individual firm. So because firms in perfect competition are price takers, they just have to take whatever price the market sets. So the market is saying you have to sell this good for $7, and this firm is like, okay, I have to sell this good for $7. So the only thing that they can decide is how much quantity to produce. So then you just draw this line out here, and then you figure out where it intersects the marginal cost. Because remember, price is equal to marginal revenue under perfect competition. So the profit maximizing quantity in every single scenario is going to be marginal revenue equals marginal cost. So now we get that our quantity is going to be, you just draw a straight line down to the quantity axis to C, and our quantity is going to be 70 units. Oh, I meant to do everything in blue so then you can distinguish. One sec. All right, there we go. Okay, so now what is the average total cost for the firm producing at the profit maximizing quantity? So now to find this, we're looking at this quantity axis here, looking at this quantity line. So we know that we're producing 70 units. So what is the average total cost at a price of at a quantity of 70 units? And it's going to be along this vertical line here. And you get that it is $5. So here's the 5, there's the 7. So our average total cost is going to be $5. Is this firm making a profit or a loss? Calculate the per unit profit or loss given the price in the ATC. Okay, so we're seeing the price is $7. So um, price is $7. Average total cost is equal to $5. So we're selling the good for $7. On average, it costs us $5 to make the good. So you can probably figure out from that that the per unit profit is equal to $7 minus 5, which gives us $2 per unit profit. And if it was the other way around, if the average total cost was greater than the price, then it would be a $2 loss. Okay, so now calculate the profit or loss for this firm. Shade in the region on the graph. Okay, so we just figured out that the firm is selling for $7 minus the $5 because profit is equal to total revenue minus total cost. So I'll just write the equation for profit out here real quick. So profit equals total revenue minus total cost. And if you break that apart, total revenue is equal to price times quantity. And then total cost is equal to average total cost times quantity. If you go back to that, those cost equations that we were doing earlier. And then you can bring that out further. You can kind of take out the quantity because quantity is in both of these equations. So you get price minus average total cost times quantity. So this is a very nice formula for profit, and I'm just going to replace it with this. So profit is equal to price minus average total cost times quantity. So now to do that calculation, we just plug in the numbers that we already got in these previous problems. So we got that our price is going to be $7 minus the average total cost, which is going to be $5, times our quantity, which is 70 units. So that's going to be 2 times 70, which is going to give us $140 for our profit. Okay, so now I probably should have shaded it in first, but you all probably know that profit always looks like this. So because the price is $7, which is greater than the average total cost, which is $5, the difference between those two is going to be the profit. So now, assume the firms in the market have identical cost structures to this one. In the long run, will more firms enter or exit the market? How do you know this? Okay, so this one, hopefully remember from class, if there's positive economic profits to be made in perfect competition, more firms are going to enter the market. So more firms enter market. Because this firm is very profitable. So we're seeing like all these other firms are starting to look at this firm and they're saying, oh, they're making so much money. This is such a lucrative industry to get into. We should also join this industry. So more and more firms are going to enter the market. And I'm trying not to get too ahead of myself. Let's read through this real quick. Yep. Okay. So we know that more firms are going to enter the market because there are economic profits at a price of $7. So because there's those economic profits, it incentivizes other firms to enter the market because everybody wants to make profit. So now on the market supply curve and demand curve, uh, draw the change in supply and label it S2. So we just said more firms are going to enter. And if you go all the way back to chapter 3, you'll remember one of the non-price determinants of supply is going to be the number of sellers. So our supply is increasing because we have more sellers selling the good. So hopefully it makes sense why supply is increasing. And uh, let's see here. I don't think you need to worry too much about the supply curve being exactly where it needs to be. You just need to have a rough idea that that supply increases. First of all, you should really know that supply increases. So let's label that supply increases. But the next thing that you should know, and we'll get into this in a sec. Goodness, one sec. There we go. All right, so we know that supply increases, and I think that's the most important thing to get out of this, but just because I can do this, might as well. S2. Okay. Oh, that's why it was the ABC. Never mind, we were right in the first place. All right, we'll explain this in a second. All right, there we go. There's our new price level. So, first of all, we just know that supply is increasing because of what we said earlier about this. And then to figure out the last part of this question, what is the equilibrium, long run equilibrium price? Remember, in the long run, under perfect competition, there are no profits to be made. So more and more and more firms are going to enter this market until there are zero profits to be made, which is where the price equals the average total cost. So you sell the good for however much it costs you to produce the good, so there's no profits. So that would be, if you see where price intersects average total cost, it's going to be at a price of $4. All right. So hopefully this clarified any questions you had on this problem, and feel free to go back or ask me any questions, like during a session or something. All right, so for chapter 14, which is monopoly, we are looking at this graph, which represents a monopoly's cost curves and also the demand. So first, we're just asked to explain why monopolists face downward sloping demand curves. So this doesn't like super apply to this specific graph. It could really be any monopolist's graph. We're just explaining generally, why does demand slope downwards for monopolists? And the reason behind this is you have to remember, so remember that monopolists are the entire demand curve, the entire market demand. And what I mean by that is monopolists are the only firm in the market, so they supply the entire market demand. So what that means is if I'm a monopolist and I want to increase the quantity of units that I sell, it's not like I can just find more customers. In perfect competition, these individual firms are so small in comparison to the entire market that we assume that if they want to sell a good to someone, they'll be able to find customers to sell that good to. But because in monopoly there's only that one firm, uh, they supply the entire market, and because of that, if they want to find new people to sell to, they're constrained by the demand. So, in order for monopolists to increase quantity that they sell, they have to decrease the price to get these new customers who weren't willing to pay at the higher price. So, we'll just state this as uh, so if, well, it says remember law of demand. So, due to the law of demand, for the monopolist to increase quantity demanded, they must decrease their price. And then also remember that monopolists are price makers. They determine the price, but they are constrained by the demand function. Okay. So now part B. What is the profit maximizing quantity for this monopolist to produce? So remember, no matter what market structure you're looking in perfect competition, we just did this. We found where marginal revenue intersects marginal cost to find the profit maximizing quantity in every single market structure. So if you're handed a graph and you're told to find what is the profit maximizing quantity, you always find where marginal revenue intersects marginal cost. So that's always your first step. So marginal revenue equals marginal cost is profit maximizing quantity. So in that case, we just find where these two curves intersect. Marginal revenue intersects marginal cost, and then you go down to the quantity axis and you see that it's at a quantity of 400 units. So now what is the profit maximizing price? Be very careful not to go just straight across and be like, oh, the price is $10. It would be nice if it was that easy, but it's not. So remember, monopolists, they're profit maximizers. They want to sell the good for as much as they're able to sell the good for. So we just said monopolists are constrained by the demand function. They can sell a good to people. They can sell goods to people for the maximum willingness that those people are willing and able to pay for the good. So you have to go all the way up to the demand curve to find the price, and then you go straight across, and you find that the price is going to be $30. So now we're trying to find the average total cost at the profit maximizing level of quantity. So you just, on this same exact quantity line here, you just find where it intersects the average total cost curve, and you see that it's at a price of $15. Calculate the monopolist's profit. Okay, so we remember that the profit equation is total revenue minus total cost, but that's also equal to price minus average total cost times quantity. And that is equal to, so we just said our price is going to be 30 minus our average total cost, which is 15, and our quantity is 400. Oh gosh, let me grab my phone. I don't want to do this calculation. 15 times 400 is $6,000 of profit. All right. Yeah. So using that equation, we get that the profit will be this area in here. Okay, so now the last question is pretty interesting. It says, if the government were to force the monopoly to produce at the socially optimal level, what would the price and quantity be? So we're trying to find what is the socially optimal price and quantity. And remember all the way back from chapter 3, the socially optimal price and quantity is where supply intersects demand. So I don't know if I want to get into this fully right now, but a helpful trick to think about is that the marginal cost of a firm is the same thing as their individual supply curve. Pretty much, for all intents and purposes, they're the same thing because the marginal cost is how much it costs you to produce an additional unit, and you're willing to sell that good for however much it costs you to produce that unit. So that's why marginal cost is basically the same thing as supply. So now you just find where marginal cost intersects demand, and you get that the optimal quantity is going to be, so I'll write Q optimal equals 800 units, and then the price optimal is going to be $20. So you can see that what's socially optimal is so what the monopolist was producing, the monopolist was producing 400 units, whereas the optimal amount is 800 units. So the monopolist is producing a lot less. In fact, it's like literally half the amount in this case than what is socially optimal to produce. And then also, so not only are they not producing as much as socially optimal, they're charging a higher price than what is socially optimal. They're charging $30 when what is socially optimal is $20. So you can see that so this problem teaches us basically that monopolists charge higher prices and sell fewer units. Sell lower quantity. I'll say lower quantity. So that's a really big takeaway from this problem here. Yeah. All right, so hopefully this problem makes sense. We're going to move on to a little bit of game theory and oligopoly. So chapters 9 and 15 are very tied together because oligopoly has these few firms. So oligopoly is few firms. So since there are such few firms, they kind of have to pay attention to what each other does, and they need to make their decisions based off of what they think the other firm will do. So in this case, we're looking at firm A and firm B. They have a duopoly in the market for economics textbooks, and we're using the payoff matrix to answer these questions. So real quick about payoff matrices. Uh, the way to read these is basically, I'll highlight firm A in red. So firm A, you're going to look at the left. Whoever's on the left side, you're going to look at the entry that's on the left. And then firm B, I'll do in blue. All right. So then the one that's on top is always going to be on the right. And the way that to kind of make sense of these payoff matrices is if firm A is trying to decide what they should do, they have to decide what they should do if firm B chooses to charge a high price, and then firm A should figure out, okay, what should we do if firm B chooses to charge a low price? Because firm A has no control over what firm B chooses to do. So they need to figure out what should we do, firm A, what should we do to maximize our profits uh, for both of firm B's potential decisions. And then, yeah, let's just get started with the problem. So firm A, do they have a dominant strategy? If so, what? So the way that I like to read these is I like to like cover up my hand with cover the page with my hand. So I'm just going to scribble out to make sense of that. So first we're going to look at what should firm A do if firm B chooses the low price. So you can imagine this like scribble out is like your hand covering half the page. So you're going to say, what should firm A do if firm B chooses the high price? So firm A could either also charge the high price and get $700, or they could charge the low price and get $900. And of course, 900 is better than 700, so they're going to choose the $900. Now you take your other hand, or you take the same hand, and you switch it to the other side, and you look at what should firm A do if firm B chooses the low price. So firm A could either charge the high price and get 300, or they could charge the low price and get $500 in profit. And of course, they're going to charge the low price. So now we're going to be looking at firm B. What should firm B do? So now you take your hand and you kind of cover it up horizontally. So now we're going to be saying, what should firm B do if firm A chooses the high price. So firm B, we're looking at 600 versus 800. And of course, firm B is going to want to prefer the $800. So now we move our hand to the top part and we say, what should firm B do if firm A chooses the low price? And we're looking at $200 versus $400. And of course, firm B is going to choose the $400. Okay, so that's how we solve these payoff matrices. So firm A does have a dominant strategy. So anytime that one firm chooses the same thing regardless of what another player chooses, we call that a dominant strategy. So firm A always charges the low price, regardless of what firm B chooses. So firm A has a dominant strategy of charging the low price because they choose low regardless of firm B's choices. Okay, so now we're looking at firm B, and same thing. They always choose the low price, regardless of what firm A chooses. So really, you can just rewrite but replace with B. So just kind of vice versa. All right, so now the Nash equilibrium. When you're looking at payoff matrices, I like to think of it as any time that there's two circles in the same box, that is a Nash equilibrium. And that's not like a definition or anything, but it helps me. It helps me to remember. So that's a helpful side note. But there's also just the Nash equilibrium from the definition. So anytime that uh, both players have a dominant strategy such that neither of them want to defect, have no incentive to defect. So the Nash equilibrium is both low price. All right. So now, does this represent a prisoner's dilemma? The answer to that is going to be yes, it does. And the reason why is because, first of all, prisoner's dilemma is when less than the optimal is chosen. So prisoner's dilemma, when both players choosing their dominant strategies leads to an outcome that is less beneficial than another outcome they could have gotten. All right, so we can see that the Nash equilibrium that they ended up at, that firm A and firm B ended up at, was $500 and $400. But if these two firms were to work together and they both charged the high price, they could both increase their profits. So that's why this is a prisoner's dilemma, because through each of them working through their dominant strategies, they end up charging the low price. But if they both worked together, they could have earned a higher profit by both charging the higher price. So, yes, this is a prisoner's dilemma, and they would have chose both high price. All right. So now we're getting into this last part. If this is a one-time game, what challenge might the two firms face when trying to enforce their decision when colluding? So, because this is a one-time game, think about it as like a promise. Like you meet some random guy in the grocery store and he asks you for a $50 loan and he promises he'll pay you back. What are the odds you're going to get those $50 back? It's from a random guy you've never met before. You'll probably never see him again. So you probably wouldn't want to lend him $50. You wouldn't trust him. But if it's like somebody who's a close friend of yours and you know that they pay you back because you've established trust with them, then you're more likely to do that. And that's the struggle with one-time games. There's a very large incentive to defect because there's no reason to build trust with the other person because it's just like a kind of one and done type of situation. So um, since this is a one-time game, there is no incentive to hold true to collusion agreement. And then a way that we can combat this is through a commitment strategy, where you say, if you break these rules, if you don't adhere to our collusion, some consequence happens, either a fine or something like that. But collusion is illegal, so it is a little bit more complicated than that. And then another way is if it was a repeated game. Establishing trust would be easier. All right, so that's it for this problem. We're gonna move on to, is this the last one? No, second to last one. All right, we're gonna take a break for a minute and I'll start a second video with the last two examples. Take a break, walk around. Thank you for listening.